In this video, we will go through 6 formulas that will come in handy when performing pH calculations. The first one is pH is equals to negative log of H+. H+ in square bracket means the concentration of hydrogen ion or proton. In other words, the concentration of the acid. Sometimes you might see this equation written as pH is equals to negative log of H3O+. It's basically the same because technically H+ doesn't exist as free ion in aqueous solution. It will definitely combine with H2O to become H3O+. However, for simplicity, I'll just go with pH is equals to negative log of H+ in this video. From the first equation, we can actually rearrange it to get the second equation, and that's H+ is equals to the anti-log of negative pH. Notice that it is not 10 to the power of negative pH, but rather it is the anti-log. The next two equations are similar to the first two. Rather than on pH and H+, they are on pOH and OH-. Notice that in these 4 equations, what we want is written on the left-hand side, whereas what we have is on the right-hand side. Now, let's say if we have pH and want to find pOH, we can easily find it through this relationship, pH plus pOH is equals to 14. Same goes to if we have one of the concentrations, we can find the other concentration using this equation. The concentration of H+ times the concentration of OH- equals 1.0 times 10 to the power of negative 14. That's actually the ionic product of water, Kw. Now let's look at how we can use the first equation. pH is equals to negative log of H+. We'll use this equation when we have the concentration of the hydrogen ion and we need to find the pH of the solution. For example, what is the pH of a 0.0235 molar HCl solution? What the question wants to find is the pH. What we have is 0.0235 molar, which is the concentration of H+. So we write out the equation, plug in the value for H+, and we get the answer 1.629. Now let's move on to our second equation, which is H+ equals to the anti-log of negative pH. This is the opposite of the first equation we just looked at. We use this equation when we have the pH and we need to find the concentration of H+. The question wants us to find the concentration of an unknown acid, which means that's the concentration of H+, and it gives us the pH, which is 4.20. So we write out that equation and we plug in the value for pH, take the anti-log of negative 4.20, and the answer is 6.3 times 10 to the power of negative 5 molar. Don't forget to include the unit for the concentration, which is capital M for molar. Our third equation is similar to the first, except it's about pOH and concentration of OH-. So we use this equation when we have the concentration of the hydroxide ion and we need to find the pOH of the solution. For example, what is the pOH of 0.195 molar base solution? The question wants us to find the pOH, and it gives us 0.195 as the concentration of base, which means that's the concentration of the OH-. So we write out the equation, we plug in 0.195 for concentration of OH-, and we get the answer 0.710. Notice that there's no unit for pH, so we just write out the number as is. Next equation, which is the reverse. So we have concentration of OH- is equals to the anti-log of negative pOH. We use this when we have pOH and we want to find the concentration of the OH-. The question wants us to find the concentration of a base, which means that's the concentration of OH-, and it gives us the pOH, which is 4.45. So we write out the equation, we plug in the value for pOH, take the anti-log of negative 4.45, and we get 3.55 times 10 to the negative 5 molar. Remember to include the unit molar for concentration. Moving on to the relationship equation, pH plus pOH equals 14. We use this when we have pH and we want to find the pOH. or vice versa. In this case, we want to find the pH, and the question gives us the pOH value. So we write out the equation, we plug in the value for pOH, and we do the math, and pH is equals to 5.8. Now, our final equation. Concentration of H plus times concentration of OH minus equals 1.0 times 10 to the negative 14. We use this equation when we have one of the concentration and we need to find the other. In this case, we want to find the concentration of OH minus, and the question gives us the concentration of H plus. So we write out that equation, we plug in 0.033 for H plus, we do the math, and we get the concentration of OH minus is equals to 3 times 10 to the power of negative 12 molar. To recap, these are the 6 equations we went through in this video. The ones in pink have to do with pH and concentration of H+. The ones in blue have to do with pOH and concentration of OH-. And the ones in purple provides the relationship between pH and pOH, as well as H+ and OH- concentration. I hope you find the video helpful. Do subscribe. Thanks for watching, and I'll see you in the next video.